Now the next question in 8th bit, so in non-terminating repeating decimal, so 3.127 bar. So here, so without bar, after decimal, without bar digits and bar digits are there. So without bar digits we have 2, without bar digits, on one digit we have a bar. So the combination of without bar and bar digits are there after decimal point. So before the numbers, so after the decimal number, whatever the digits are there, that complete digits have a bar. So that complete digits are, so repeated digits we are getting. But here in this question, so here 2 digits have without bar and 1 digit have a bar. So then if a question is like that, then what to do? See here. So whatever the question is given, first we assume that that is x. X is equal to 3.127 bar. So that means x is equal to 3.1277777. It continues infinite times. This you take it as equation 1. Here without bar digits after decimal, on how many digits we have without bar? On 2 digits we have without bar, on 2 digits we have, so no bar, nothing. So we should multiply with 100 on first. So multiply equation 1 by 100, that implies 100 into x is equal to 100 into 3.12777 so on. So then if you multiply with 100, so the decimal point will move 2 digits from left to right. That is 100 into x is 100x, which is 312.777 so on. This is equation 2. Now after that, so here on 1 digit we have a bar. After that here, so on 1 digit we have a bar. Again the next time again, so we should multiply with 10 to this equation 2. So again equation 2 should multiply with 1. Why? Because on 1 digit we have a bar. So multiply equation 2 by 10, that is 10 into 100x is equal to 10 into 312.777 so on. So 10 into 100, that is 1000. 1000x is equal to, if you multiply by 10, again the decimal point will move one place from left to right, that is 3127.777 so on. This is equation 3. Now what to do? Equation 3 minus equation 2 we should do. Equation 3 minus equation 2. What is equation 3? That is 1000x is equal to 3127. 3127.777 so on. Equation 2, 100x is equal to 312.777. 312.777 so on. Now subtract 7 minus 7 0, 7 minus 7 0, 7 minus 7 0, 7 minus 2 5, 2 minus 1 1, so borrow 11. So 11 minus 3, 11 minus 3 8, and here 2 is equal to 1000 minus 100, 990x, that is 990x is equal to 2815. Then x is equal to 2815 by 990. Now these two are divisible by 5. 5 ones are 5, 5 ones are 5, then 4, 5 nines are 45, 4 left, 5 eights are 40, 5 eights are 40, 5 fives are 25, 3 left, 5 sixes are 30, and 5 threes are 15, 5 threes are 15. Then answer is x is equal to 563 by 198. What is our x? Our x is 3.127 7 bar is equal to 563 by 198. This is in the form of P by Q. Okay. Now, so the next question, so without actually dividing, find which of the following are terminating decimals. Here, terminating decimal. So, what the terminating decimal, how to say that either the given fraction is a terminating decimal or non-terminating decimal. So, if the given fraction, if the denominator is in the products of 2's, 5's or the combination of 2's and 5's, then they are terminating decimals. Otherwise, they are non-terminating decimals. If we can write the denominators, the product of 2's or the product of 5's or the product of 2's and 5's, then that is terminating decimal. So, that is why first we should check either the denominators are in the product of 2's or the product of 5's or the product of 2's or 5's. If the combination is like this, so then we can write the fractions, means rational numbers, in terminating decimals. Otherwise, they are non-terminating repeating decimals. See here, 3 numerator we should take as it is, and 5 we can write as a product of 5's. 5 5's are 25. Here the denominator is the product of 5's. So, it's terminating decimal. So, it is terminating decimal. So, now here 11, here, so 18 how to take 18? So, 2 3's are 6, 6 3's are 18. So, here the denominator is the product of 2's and 3's. If 2's and 3's, so the denominator should be product of either 2's or 5's or 2's and 5's. So, other than that number will come in the denominator, so then they are not terminating decimal. So, here the denominator is the product of 5 and 3. So, it is not terminating decimal, not terminating decimal. It is not a terminating decimal. It is a non-terminating repeating decimal. Okay. Next. So, 13 by 20 means 2 2's are 4, 4 5's are 20. 2 to the 4, 4 5's are 20. So, here the denominator is combination of 2's and 5's, 2's and 5's. Here the denominator is the product of 2 and 5. So, it's terminating decimal. It is terminating decimal. Next, 41 by 42, that is 41 by 2 3's are 6, 6 7's are 42, 2 3's are 6, 6 7's are 42. Here the product of 2, 3 and 7. So, the product of the denominator should be in terms of 2's and 5's. Other than that, that is a non-terminating repeating decimal. So, it is not a terminating decimal. Here the denominator is the product of 2, 3 and 7, 2, 3 and 7. So, it is it is not a terminating decimal. So, how can we say without doing a division? So, just we split the denominator prime factors. If the denominator prime factors are 2's and 5's are 2's, then that is a terminating. Other than that, like 2 and 3's, 2, 3, 7. So, if the prime factors of the denominators are in such a form, so then they are not terminating one. So, only how can we say that the given fraction is it terminating or non-terminating without doing a division? So, just we split denominator into prime factors. So, if the prime factors of the denominator in terms of 2 or in terms of 3 or in terms of 2 and 5, not 3. So, in terms of 2 or in terms of 5 or in terms of 2 and 5 combination, so then rational number is a terminating decimal, either that is a non-terminating repeating decimal. Okay students. Yes students, our next concept, irrational numbers. So, before what we discuss rational numbers. So, then how to represent rational numbers? So, what are the terms and conditions about the rational numbers that we discuss? So, rational numbers, generally rational numbers are represented in the form of p by q. So, when the number is in the form of p by q, then that is a rational number. So, then what are the rational numbers? Rational numbers are all set of natural numbers, set of whole numbers, set of integers, and decimal numbers, all decimal numbers. So, then after that fractions, all fractions, terminating fractions, proper fraction, improper fraction, mixed fraction, and so all that fractions are rational numbers. And also, so what are the rational numbers? The numbers which are having perfect square root values, perfect cube root values, perfect fourth root values, fifth root values, sixth root values, all these are rational numbers. In short, so rational numbers is in the form of p by q. So, and also what we discuss? We discuss how to represent rational numbers on a number line. So, if rational number is given, then how to represent on number line. So, then how to find rational numbers between the given two numbers, that we discuss. And also what we discuss, how to convert the rational numbers into decimal form, rational numbers into decimal form. So, either it is a terminating decimal or non-terminating decimal. What are the conditions? In terminating decimals, what are the conditions? In non-terminating decimals, then what are the general condition? In terminating decimal, if the denominator of the fraction is in terms of the prime factors 2's, 5's or combination of 2's and 5's, then that can be a terminating decimal. So, if the denominator of the fraction is not in the terms of the prime factors 2 or 5 or the combination of 2 and 5, then that is not a terminating decimal. So, that is non-terminating decimal. All these concepts till now we discuss. Now, the next concept we are going to discuss, that is irrational numbers. So, what are irrational numbers? What are irrational numbers? What type of numbers are irrational numbers? So, before we discuss what are irrational numbers. So, irrational numbers are the numbers which are neither be terminating nor be a non-terminating. So, the decimals which are neither be a terminating nor be a non-terminating decimals are irrational numbers. And also the numbers which are not having perfect square root values, cube root values, fourth root values, fifth root values. So, all this type of numbers comes under irrational number category, irrational numbers category. Okay. Now, here the first question, x square is equal to 4, 3x is equal to 4. So, what it be? Either it is a rational number or irrational number. Suppose, so if we take square root on both the side, square root of x square is equal to square root of 4. So, whenever square root will come, then we should take plus or minus. Plus or minus. Why we should take plus or minus? Because minus 2 whole square is also plus 2, plus 2 whole square is also plus 2. So, like minus 2 whole square, that is minus 2 into minus 2, that is minus into minus plus 2 2s are 4 plus 4. Then plus 2 whole square, that is plus 2 into plus 2. Here there is no sign, means plus sign is there, plus into plus plus 2 2s are 4. It means in minus 2 and in plus 2 case the square will be plus 4 only. So, that is why we should take plus or minus, we should take plus or minus. Now, after that, yes, square and square root will get cancelled, square and square root will get cancelled. How the square and square root will get cancelled? So, actually x square root means always we should take power 1 by 2. So, square root means power 1 by 2. So, 2 will get cancelled, so x will left. So, that is why in direct form square and square root will get cancelled always. Then x is equal to plus or minus square root 4. Square root 4 value is 2. Square root 4 is 2. So, that is plus or minus 2. Plus or minus 2. It means x is equal to plus 2 or minus 2. So, what are our x values? Plus 2 or minus 2. X is plus 2 or minus 2. So, plus 2 and minus 2, these values are rational numbers. These values are rational numbers. So, plus 2 is a rational number and minus 2 is also rational number. It is rational number. Why? Because plus 2 and minus 2, so they are, one is a positive integer, other one is a negative integer. Positive integer and negative integers, both are rational numbers, both are rational numbers. Okay. Now, after that, 3x is equal to 4. The second question, 3x is equal to 4. So, then, so if you divide, say divide by 3 on both the side, so then what it will be? 3x divided by 3 on both the side. 3x by 3 is equal to 4 by 3. Both the side by 3 by 3. That is 3x by 3, 4 by 3. So, then here 3 will get cancelled. So, then what is left here? X. X left here, x is equal to 4 by 3. So, this is in the form of p by q, this is in the form of p by q, x is equal to 4 by 3. So, then if it is in the form of p by q, then it is a rational number, then it is rational number. So, then either it is a terminating or non-terminating. So, because in the denominator we have 3, so it is 2 and other than 2, 5, other than 2, 5, other than 2 and 5. So, this is non-terminating decimal. This is non-terminating decimal. Why it is non-terminating decimal? Because in the denominator we have, so other than 2 and 5, 2 and 5. So, that is why it is a non-terminating decimal. So, non-terminating decimals are rational numbers. Non-terminating decimals also rational numbers. So, x is equal to 4 by 3. This is the rational number. So, x is equal to 4 by 3, x is equal to 2 minus 2. So, this all we can represent on number line. This all we can represent on number line. It is very easy to represent on number line. Why? Because these are rational numbers. Then after the third one. So, the third one, what is the third one? Here we should take square root on both the side, square root on both the side to find x value. That is square root of x square is equal to square root of 2. Here we should take plus or minus, plus or minus. Then here square and square root will get cancelled, then x is equal to plus or minus root 2. Here root 2 is there, root 2 value. What is the root 2 value? So, this root 2 is not a perfect square root value. So, if it is not a perfect square root value, then what it is? It is an irrational number. It is an irrational number. Then the number is an irrational number. Then how to represent on number line and also how to find the value of root 2. So, that we are going to discuss. Okay. So, this is irrational number. Why it is an irrational number? Because here square root 2 is there. Square root 2 means, so root 2 is not having any perfect square root value. So, that is why it is an irrational number. When the number is irrational number, then how to represent on number line and how to find what is the value of root 2, then how to find the value of root 2. So, that we are going to discuss. Okay, students. Finding square root value by division method. So, then how to find square root value by using division method. Square root value by division method. See here. So, how to find square root value by division method? See here. First of all, so we have to take 2. So, then after that point, take point. So, 2 point what is there? So, nothing is there, means we can take number of zeros. So, 2.00, 00, 00, 00, 00, 00, number of zeros we can take, n number of zeros we can take, n number of zeros, so we can take. Okay. So, now, so after that, so this is finding square root. So, take here, draw one more line here like this. Now, after that, so these zeros will continue infinite times. These zeros will continue infinite times. So, on pair of zeros we take a bar like this. So, on 2 zeros 1 bar. So, 1 bar, 1 bar, 1 bar, 1 bar, 1 bar, and here single. So, on each pair we should take a bar. So, on each pair, in each pair of zeros we should take a bar. Then after that, then how to divide? So, make a rough column. Actually, we should make a rough column on so right side. So, but here, so we don't have a space. So, here I am doing rough column. So, okay. So, first we should take this 2. So, where the 2 will go? So, 1 1 za 1, 2 2 za, 3 3 za, 4 4 za, 5 5 za, 6 6 za, 7 7 za, like this we should check. How we should check? 1 1 za, 2 2 za, 3 3 za, 4 4 za, 5 5 za, like this. So, the equal, so with the equal number we should multiply. So, 1 1 za 1. So, how it is? 1 1 za 1, 2 2 za 4. 1 1 za 1, 2 2 za 4, but here we have 2. So, it is near to 1 1 za. So, we should take 1 1 za. 1 1 za, 1 1 za 1. So, that one we should write here, 1 1 za 1. Okay. So, 1 1 za 1. So, the first part is over, 1 1 za 1 is over. Now, after that you should subtract, minus 2 minus 1 is 2. 2 minus 1 is 2 minus 1 is 1. So, 2 minus 1 is 1, that one we should write. Then after that, the decimal after the decimal, so whatever the pair is there, that we should take. So, what is the pair after the decimal? So, the pair is, so 2 zeros, that 2 zeros we should take here. So, the 2 pairs we should take, and so this is over. So, the first step, first what we should check? First we should take, we should check, so where the 2 should come. So, 1 1 za or 2 2 za or 3 3 za or 4 4 za. First you write here and check, 1 1 za 1, 2 2 za 4. 2 2 za 4 is more than the given 2. So, we should take 1 1 za. So, write 1 1 za 1. Then after that subtract, 2 minus 1 is 1. Then after that, after very next, so after the decimal places, after the decimal whatever the places were there, that places we should copy. How many places we have? 2 places, that are 2 zeros. That 2 zeros we should copy. Okay. Then after that, what we should do? Again this 1, so we should take here and add 1 plus 1. So, 1 plus 1 is 2. That 2 we should take. Here the decimal places we are taking, so you keep decimal point here. So, 1 point. Now, after that, so we should add 1 and 1. So, already 1 is there, again we should take whatever is there here quotient, that we should add each and every step. Okay. So, here 2. Now, in 2 table, when you will get this 10? So, in 2 table, so when you will get this 10? 2 5 za. So, 2 5 za means 5 za. Here you will get 25, means 25 5 za, we have to check how much it is. 25 5 za, 5 5 za 25, 2 5 2 za 10, 11 12, 125. 125 here 100 is there. So, we should take one less. 25 4 za we should take, 24 4 za. Here we should take 4. and here also we should take 4. Both the side we should take 4. 24, 4 is a 4 4 is a 16 and 1. 4 2 is a 8, 8 plus 1 9, 96. 96. It means here we should take 96. So 24 4s are no. So that 4 we should take here as well as here also. Both the side we should take 4. If you want to take 5, then here also 5 and here also 5. So how to guess either it is a 5, either it is a 4? First we should check to, so when this 10 will come. 5s are. It means 25 5s are we should check. So that is more than 100. So now it's 4. That means so one less we should take. So then 24 4s are we should check. So like this we guess and we should take. Then after that minus it. So you will get 6 here. You will get 6 here. On each and every step we should add the quotient whatever is getting. So 4 we got. So 4 we should add. 24 plus 4 that is 28. 28. Now here the difference is 6. Then after that, so we should take 2 zeros. So that 2 zeros we should take. So we should take 2 zeros. So after whatever is there, that 2 zeros we should take. Okay. Now in 28 table when you will get this, in 28 table when you will get this 60, 28 2s are almost. So we should take 28 2s are 28 282 2s are 2 2s are 4, 2 8s are 16, 2s are means here 2 and here 2 you will get. So 2 to the 4, 2 8 are 16, 1, 2 to the 4, 4 plus 1 5. 562, 562. So now the students see here, see in the previous step, see 24 4s are, what is 24 4s are? 4 4s are 16, 4 2s are 8, 8 plus 1 9, 96. Here 24 4s are 96 here. This is not 94, okay students? This is 96, 96. Then 10 minus 6 is 4, 400, 400. So now according to that we should check. So now in 28 table when you will get this 40, 28 1s are 28, 28 2s are 56, 56 is more, means 28 1s are we should take. 28 1s are means here 1 and here 1 we should take. So here 1 and here 1. So then 281 1s are 1 1s are 1, 1 8s are 8, 1 2s are 2, 281. 281 1s are 281, 281. Now again subtract 9. So here you will get 1 and 3 minus 2 1, 119. On each and every step whatever the coefficient will get, that we should add. So that is 1, 282. So then after that next pair. So this pair is over, this pair, next pair we should take, that is 2 zeros. Now in 282 table, so when you will get 11,900. Don't take that much big. So just you take 282 table when you will get 1190, 1190. So it's simple. So otherwise no need to take total 3 digits, in a single digit you check. In 2 table when you will get this 11, 2 5s are 2 5s are 10, 2 5s are 10, 2 6s are 12, that is more. 5s are means here 5 you will get here 5 and here 5. So once you check with 5, 2 8, 2 5 with 5, 5 5s are 25, 2, 5 to the 10, 11, 12, 5 to the 40, 41, 4, 5 to the 10, 10 plus 4, 14, 14,128. Here 11,000 is there, here 14,000. The 5s are we are getting more. So that means we should take 4s are. Here 4 and here 4. So now you check with 4. So 2,824 into 4. 4 4s are 16, 4 2s are 8, 9. 4 8s are 32, 3. 4 2s are 8, 9, 10, 11. 11,296. It means 11,296 is the So lesser value, so that we should take 11,296. 11,296. Now after that, now students see here, so when we subtract 11,900, then from 11,296 from 11,900, then check what is the answer here. So here 10 minus 6, 10 minus 6 is 4, 9 minus 9 is 0, 8 minus 2, 8 minus 2 how much? 6, 1 minus 1 0, 1 minus 1 0. Here 11,000. So where the 11,000 will get? Here this is the first step 1, fourth step 4, first step 1, fourth step 4 you will get. So then after that more 2 zeros we should take. More 2 zeros we should take. So then in the step what we are getting 4. So that we should add. So 28,200 so 2,828 that we should take. So now, so in 3s we should check. In 3s what we are getting? So that is not getting in 2s. So 2s we will get 2s. That is 28,280 to 2s, 2 2s 4, 2 8s 16, 2s 4 5, 2 8s 16, 56,564. 564. Now subtract 0 here means 10, here you will get 9, so he will get 13, here you will get so 9, here nothing 5. 10 minus 4, 10 minus 4 is 6, 9 minus 6 is 3, 13 minus 5 is 8, so 9 minus 6 is 3, 5 minus 5 is 0. Then after that more 2 pairs we should copy. So then in the next step whatever the quotient is that we should add 28284. So that is 28,284. So now here how many digits we have? 1 2 3 4 5. 1 2 3 4 5 6. It means in 2 table, so when you will get this, so 3, so 1s are, so 2 1s are 2, 2 2s are 4, so it means 4 is more, so we should take 1s are, here 1 and here 1. Now 2,82,841 1s are, 2,82,841 that you will get. Then minus, here you will get 10, 10 minus 1 is 9, 9 minus 4 is 5, 15 minus 8, 15 minus 8 is so 7, here 2 minus 2 0, 2 minus 2 0 no need to take. So then after that here 2 minus 2 0, 8 minus 8 0, 3 minus 2 1, that is 10,000, 1,07,500 1,07,59 you will get, 1,07,59. If you again take more 2 zeros, again it will continue, so it will continue infinite times. So what is square root 2 value? That is 1.4142113, so on, it will continuous infinite times. So how many times it will come? So it will continuous infinite times with the long division method. So here when we are doing this problem, so we should be focused on subtraction as well as multiplication and also division. All these 3 concepts are very important. If you do a single mistake in minus, in plus, in multiplication, again we should do again and again. Here the process is important. So what is the process here? So just we have to check at the beginning, we should take bar on so pairs, 2 zeros, on 2 zeros we keep a bar, on 2 zeros we keep a bar, on 2 zeros we keep a bar, like this we keep bars on pairs. Then after that, so extreme left digit, whatever is there extreme left digit, so that we have to check when it will come. Either it will come in 1 1s or 2 2s or 3 3s or 4 4s. Near to that value we should take. Here 2 is given, that means 1 1s we are getting, 1 1s 1. So now you take 1 1s 1, 2 minus 1 is 1. Now so each and every step whatever the quotient will get, that we should add, 1 plus 1 2. Now after that, on each and every step where that 100 will get here into table. So on each and every step you check like that and multiply and check either the value is lesser or more. If more, then you take less and multiply and take your quotient and add the quotient here and again continue the process. So if you want to do 3 steps, 4 steps, 5 steps, 6 steps, 7 steps, that's your wish. How long you want to do your division, so that you can do. So but here the important is subtraction and multiplication. Here multiplication, so we should check so where the number should come. So that particular number we should take, and also subtraction. So when we are going to do the subtraction, be careful. So no need to, if you get error, then again it is a big problem. So it is very big question. So one small error can do again, you should do again your problem. So that is the one drawback is there. So be careful when you are doing this problem. Okay, here also we did, so when we did here, so we did some mistake. 8 minus 2 we took there 4 first time. So don't do that errors. So 8 minus 2 6 like that. So subtraction and multiplication, so both you should do perfectly. Okay, so what it means, square root 2 value is 1.414213, it will come infinite times. So infinite digits we are getting. So root 2 is an irrational number. Why it is an irrational number? Because square root 2 is not having a perfect square root value, and also it is neither a terminating decimal nor a non-terminating decimal. So that is why root 2 is an irrational number. Then how to find square root value using long division method? This is the method to find square root value by using long division method. Not only this square root value, more square root 3, square root 5, square root 7, square root 11. So whatever the value is given, so we can do by using long division method. For finding square roots, we should use long division method. Okay. Yes. Now the students, so irrational numbers. About the irrational numbers, square root 2 value, so we find so by using long division method. So what is square root 2 value? Square root 2 value is 1.41423. So till 4.4123 we did. So and if you continue square root 2 value, that is 1.414235623731, so on it continues. And square root 3, 1.732050807568, so on it continues. And square root 5, 2.23606797749998, so on it continues. So square root 2, square root 3, square root 5, all these square root values are not perfect square roots. So if we do, so by using long division method, so the values will continuously goes on and goes on and goes on infinite times. So that is why square root 2 and square root 3, square root 5 are irrational numbers. Irrational numbers. Here irrational numbers, when the irrational numbers, so when the irrational numbers discovered, who discovered? So when and who first discovered irrational numbers? First irrational numbers are discovered in 5th century BC. Pythagoras followers, so they discovered so irrational numbers in Greece. First in 5th century. In 5th century, so Pythagoras followers, so they introduce irrational numbers. They introduce means they discovered irrational numbers. First they proved root 2 is an irrational number. First what they proved? They proved that root 2 is an irrational number. So great mathematician Pythagoras, a great philosopher, mathematician, so followers, they proved that root 2 is an irrational number in 5th century BC. So they discovered irrational numbers. And after that Theodorus Seren, so he discovered root 3, root 5, root 6, root 10, root 11, root 12, root 13, root 15 and root 17. All these are irrational numbers he proved. Who proved? The Theodorus Seren. He proved. So remaining root 3, root 5, root 6, root 10, root 11, root 12, root 13, root 15 and root 17 are irrational numbers. So about the irrational number concept, when the irrational numbers discovered in 5th century. Who discovered Pythagoras? Great mathematician, philosopher. So followers. So they introduced, means they discovered so irrational number and they proved root 2 is an irrational number. After that, who discovered other irrational numbers? Who discovered? Theodore Seren. He introduced, means he discovered so more irrational numbers like root 3, root 5, root 6, root 10, root 11, root 12, root 13, root 15 and root 17. So in common in 1800 BC, so irrational number reference is there, irrational number calculations reference is there in Sulabh Sutra. In Sulabh Sutra, so irrational number calculations reference is there. Okay. So now after that, so this is about irrational numbers. So how the irrational numbers are? If we observe these decimal points, so they are not in a proper, means they are not a terminating, they are not non-terminating decimals. So they are not under, means they are not considered as a terminating decimals, they are not considered as non-terminating decimals. So this type of numbers are irrational numbers. So then after that, when we observe this chart, so then we can easily understand the difference between rational and irrational and square roots numbers also. Here square root 1 we know that is 1 and square root 2 is, so we did that square root 2 by long division method, that is 1.41423 so on, it continues, and square root 3 is 1.7320508 so on, it continues, and square root 4 is 2 2s are 4, and square root 5 is 2.2360679 so on, it continues, and square root 6, square root 7, square root 8, these values also, so decimal numbers, it continues on infinite times, square root 7, square root 8 all, and square root 9, that is 3 3s are 9. If we observe in this chart, square root 1 is 1, square root 4 is 2, square root 9 is 3. So these three are rational numbers, other are irrational numbers. So why they are irrational numbers? Why? Because they are not perfect square roots, and if we do by long division method, so we are getting decimal numbers, that decimals are neither terminating nor non-terminating decimals. So that is why the numbers which are not having perfect square root values are irrational numbers. Okay, irrational numbers. So what type of numbers are irrational numbers? The numbers which are not having perfect square root values, they are irrational numbers. Okay students. Okay, now students, see here, so one question he has given. So what is that question? Kruti said root 2 can be written as root 2 by 1. So which is in form of p by q. So root 2 is a rational number. So do you agree with her? So no. So we cannot agree with her. So why? Because root 2 is an irrational number. So but she says that root 2 by 1, it is in the form of p by q. Root 2 by 1. So root 2 by 1, it is in the form of p by q only. When it is p by q form, then no doubt it is a rational number. So why we say that root 2 is a irrational number? P by q is a rational number, it is an irrational number we are saying. So because root 2, if you take root 2 by 1, so after we are cancelling with 1 whatever it is, so we are getting non-terminating, neither a terminating decimal nor a non-terminating decimal. So neither a terminating decimal nor a non-terminating decimal. So if our number is neither a terminating decimal nor a non-terminating decimal, that is irrational number only. So if by 1 is there, whatever is there. So but root 2 by 1 means root 2 is not a perfect square root value. If by 1 is there also, if we simplify, so then the decimal is neither a terminating nor a non-terminating decimal. So that is why it is an irrational number only, it is not a rational number. Okay. Next, here, so know about pi. So what is mean by pi? So here pi, actually what is pi? Pi is the circumference of a circle and to its diameter. So pi is equal to c by d, c divided by d. See what is c here? C means circumference of a circle to its diameter. So what is the diameter? That is d. The ratio of c and d, that is circumference of a circle and diameter. So that gives you, so the pi, that gives you pi value. So, what is pi value? Pi means the ratio of circumference of a circle and diameter of that circle. So, gives pi value. Here pi is an irrational number, pi is an irrational number. So, it is not a rational number, it is an irrational number. So, why it is an irrational number? So, if we measure accurately circumference of a circle or diameter of a circle, so anyone can, so anyone is a, so surely either a C or D is an irrational number, either it is C or it is D is an irrational number. Anyone in circumference of a circle or diameter of a circle, anyone is an irrational number. So, that is why pi is an irrational number, pi is an irrational number. So, pi is, no doubt it is an irrational number. Why it is an irrational number? Because pi is the ratio of circumference of a circle and diameter, circumference of a circle and diameter. So, if we measure circumference of a circle as well as diameter of a circle, so anyone, either a circumference of a circle or diameter of a circle, anyone is an irrational number. So, that is why pi is an irrational number here. So, who first calculate the pi value? So, first a great genius, mathematician Archimedes first he find the value of pi, So, what is the value of pi? So, what is the value of pi? The pi values he shows who? So, Archimedes, he shows that pi value lies between 3.140485 and 3.142857. The pi value lies between these two numbers. The pi value is between 3.140485 and 3.142857. So, it lies between these two values. Which value? Pi value. Who? So, a great genius Greek mathematician Archimedes, first he find pi value is in between these two values. Then after that Aryabhatta, great Indian mathematician and also astronomer. So, who? Aryabhatta. So, he find pi value up to 4 decimal places. So, that is 3.1416. So, what he says the pi value is 3.1416. Who says? So, Aryabhatta. So, who is Aryabhatta? Aryabhatta is a great Indian mathematician and also astronomer. So, he find the value of pi. So, that pi value is 3.1416. Okay, and also he find the value of pi. So, till how 1.24 trillion decimal places up to he calculated. So, with a fast computers, with high speed computers and also advanced algorithm, using these two techniques he find the value of pi. So, how many places, how many decimal places? Till 1.24 trillion decimal places. So, trillion decimal places means, so like pi value is 3.14152965358979328546264333853. So, like this 1.24 trillion decimal places, till trillion decimal places he find the value of pi. Who? Aryabhatta. So, with the help of at high speed computers and also advanced algorithm using, so these two he find the value of pi up to 1.24 trillion decimal places, So, then after that, so on every year on 14th May, on 14th March 14th we celebrate as Pi Day. So, we celebrated as Pi Day. So, when March 14th, every year on March 14th we celebrated as Pi Day. So, since that so we calculated our pi value as 3.14. So, that is instead of 3.14159, instead of this value 3.14159, so we took our pi value as 3.14. So, 3.14. So it is, so what we can say, Albert Einstein also born on 14th March only. Albert Einstein, he also born on 14th March 1879. So So it is not mean that so he born on 14th March. So coincidentally it's happened. Coincidentally it's happened. So Albert Einstein, so when he born 14th March 1879. So our Pi Day is on 14th March only. So it is not mean that so he born on 14th March. So that is why we are celebrating as Pi Day. So it is coincident only. It is a coincident. So 14th March is a Pi Day, and also Albert Einstein is also born on 14th March 1879. This is about our pi history. Pi history. Pi is an irrational number. Why it is an irrational number? If we measure or if we calculate the circumference of a circle or diameter of a circle, any one is an irrational number. Surely any one. So in these two are irrational numbers. So no doubt pi is also an irrational number. Okay.